Hi everyone, this is AKHIL Duggishetti and I am from Weltech University, Chennai, located in Chennai. Now I am going to explain my major project Optimal Secure Password Authentication Protocol. It's given the title as like this. Then this project, discussing about this project, actually this project is mainly given by the research internship from my college, where it is collaborated with East Stroudsburg University, which is located in USA. And the duration of the internship was between January 2022 to May 2022. It's almost 5 months. And my industry guide is Professor J. Cheladurai sir. And now coming to the title of the project, I already said optimal secure password authentication protocol. And now where I'm going to explain the abstract of my project. Like we know that the title sponsors itself says that optimal secure password. That means we are going to secure the passwords from the third party vendors or some other like from other like hackers or any other persons to not to hack our passwords and not to let our information to give them. These are the most convenient ways to provide a secure access to the user into a particular device or a site. Thus, we are going to strengthen the user and provide a proper mode of security in a cyberspace where as well as request with third party hundreds, and these are the cheaper when compared to biometric authentications like when we used to keep a fingerprint and webcam scanners, etc. All this. And authentication system mainly of use of two-factor authentication and multi-factor authentication to keep the data of the user secure or makes use of hash algorithms, etc. Then coming to the next thing, our aim of the project is in order to maintain the security of a network, and it is very important to secure the network to the proper use of authentications and provide a good access to the key users. Whatever the users are well, we are going to just keep them avoid the users to attack from the hackers or some other third party websites or some other uh, malfunctions, etc. like this. Scope of the project is to create a secure authentication protocol. And actually, I'm going to say about let's give me already given a little bit of introduction about this. Then we are going to mainly use of ECC, that is nothing but electrical cryptography method. This is based upon the algebraic structure of an electrical curve over a finite fields. Mainly the ECC implements three types, like one is signatures, encryption, and one is key exchange. And our actually this research internship is based upon the old paper, like actually how it stands, like we have taken old paper and we have just implemented some improvements we have done, and they have old paper have included the let me show you the old paper. This is the old paper what they have done. Sanvik Jain and Avin Avani Kasat in 2021, they have just used a RSA as like you can say reverse Samir Almer encryption. This is the type of algorithm. It's an asymmetric cryptography method they have used in their project. But coming to my project, we apart from this RSA, we are going to use ECDSA algorithm. That is nothing but elliptical curve digital signature algorithm. And let me say why this is more effective than RSA. Like ECC or ECDSA will use small keys and signatures, and it will very fastly create the generation of keys compared to the of RSA. Like whereas RSA uses a very large quantity of keys and signatures, etc., and it is very slow compared to ECC actually. So we can simply say that it is a successor of ASA, which is nothing but an asymmetric cryptography. And in this we are going undergo many different things, like we are going to have some ECC keys, and as you can see there's a methodologies where the module 1 includes generation of a private and a public key, and module 2 includes elliptic curves and key lengths, encryption, decryption. Let me explain in detail about this everything. So before we are going to that basic things, we need to understand what are the ECC keys actually. ECC keys are will have two different types. One is a private key and one is a public key. These private keys are all of integers with 256 bit, and the public keys are a pair of integer coordinates, like if you are going to have an x and y axis, then lying on the curve. Then public keys can be compressed. Actually, this public keys can be compressed into private keys also. Like actually, the public key will be like 256-bit ECC private key. When we are compressing that to private key, it converts into 257-bit integer. Okay. Then coming to the curves and the key lengths, this is one more factors which is involved in the project. And this ECC cryptography algorithm, this curves provides different security, different performance, different speed, and different key lengths and different algorithms, etc. And coming to ECC algorithm, I already said we are going to use about ECDSA, that is nothing but elliptical curve digital signature algorithm in this project. Then we can see in detail this module, this screen you can see on the screen you can see, and how we are going to generate a public and a private key. The public key is the ECC or ECC pairs, and how we are going to use the by creating the using of a formula. And now we are going to elliptical curve key and length, and here we are going to do encryption decryption. For this we are going to use some formulas. Before going to that, I'm going to say like here EC, in this EC, G stands for generator, point and K stands for private key, and it is nothing but an integer. P stands for a public key, that's nothing but a point in the curve or a graph. And multiplication of ECC points we are going to use by tiny EC provides that we are going to use this tiny EC. This is the type of a library we are going to use in the Python. Actually, what it provides is like cyclic groups or elliptic curves or finite fields, and also it provides some EC points. Okay, so we are going to have an equation called equation we are going to have as x square equal to y square equal to x cube plus 7 of mod a mod b, like something, that equation will be there. Then here we're going to have some order of n equal, and order of n is nothing but order, and h is nothing but a cofactor. And let me show you that how it's going to be. Yeah, here this is a graph. Actually, this is a graph y square equal to x cube plus x plus b. This is already I said just before. And this is a curve called spec 256k1. This is a key pair or key that is used in a Bitcoin for an elliptical curve. So every Bitcoin has different types of curves. So let us take a doggy coin, or let us take a Bitcoin, some other coin, PTC, etc. This everything will be having different types of keys, right? So that for different keys they'll be having different curves actually. So this curve is nothing but a spec 256k1. So in this spec 256k1, and the value of, you can see here, a value is 7, sorry, a value is 0, b value is 7, and we are going to visualize this now. I'm going to show you how this works. Okay, yeah, you can see here, this is the equation, and we know that the value of b is 7, right? So let's keep the value of b is equals to 7, and we know that the value of a is 0, so let's make it as 0. Okay, now you can see this is the curve actually showed before one, and we are going to collect the values. Like we are going to have a straight line passing to the curve, like you can take anywhere. Okay, that line can be anywhere from the axis in the different coordinates, and you can maybe a negative or a positive, or anywhere coordinate we can take. But we need to have some values like x1, y1, y2, x2, y2, and different things. Okay, and now we are going to calculate the equation of a line. Like you can see that puts both the sources y equals, we are going to calculate the value of this one. So this value we are going to calculate for each and everything. Okay, then we know that slope of the equation is m equals to y1 minus y2 and x1 minus y2. We are going to calculate the slope there, and just we will discuss this everything. So in this way, this the graph looks, and through which the points are calculated, and where we can use them in the in the generation of a key pairs in the public and a private key. Then coming to the coding part, so this everything is executed and is in a particular manner in a coding way, like perp install tinyweeks. So tiny is the type of library. I already said it is using the Python, which provides cyclic groups or elliptical curves over a finite fields and easy points, right? So what it does is it generally creates a subgroups of a curve. So or else it is going to create a curve. This entire curve is used by creating this tiny EC. Okay. So you can see here the what are the points generated and etc. Everything is there here. Yeah, this you can see here subgroup, and every point is generated here, and the values of p is I already said is a public key and the key is a private key, etc. Everything. So G is a generator point, 5 and 9 are the generator points, N is a cofactor. I already said H is nothing but a cofactor and N is nothing but an order. So everything you can see by using them we are going to create a curve and we are going to create a points from there. Okay. Then coming to this registry. This is also type of Python library. Before that, this entire code is working in a Python actually. So in a collab. So this Python in this registry library, it is used to modify a registry type outside the activity system. So in this library is intended for registry update scenarios such as you can say servicing an operating system images. The library supports the high formats starting in the Windows Vista. And our aim is to create a public and a private keys. Just like a private key, public key is already generated by the user, and the server will be having the user need to send this public key to the server side. You can send the way of internet through the means of internet, some other mail, etc. in an encrypted way, so that after reaching there, he can be decrypted. So public key can be known to everyone. The name itself specifies that public, so it can be known to anyone. Using this tinyness and registry, we are going to create a public and private key for spec 19R 19. So spec 19 to R1. This is also type of key that is or a curve we can say that is in the Bitcoin. This is for the particular Bitcoin. Okay. For that we are generating a private and a public key. And here numster. That's nothing but a numerics, and where we are going to have this everything. Yeah. Now coming to this part, you can see here original part and compressed and uncompressed parts. Yeah. For this scenario, we have taken Alice and Bob as two different things, like when a client side and one is the server side, and we can see here, Alice public key is this. This thing is nothing but the Alice public key actually, and the Bob public key we can see this is a Bob public key. Now extend the public keys. I already said we can extend this public keys through internet, so that only the client and sorry server side can be matching, like he can match with the public key with the private key, and if it matches only the he can what am I going to say, I can authenticate easily. So that is the main thing what I'm going to express in the whole project. Like Alias shared keys, you can see here. What are the shared key? This Alias has shared one key, right? To Bob. This is the shared key actually. Then this is the Bob shared key. If this both are matches only, then he can authenticate easily. Then we're going to create a public, private, and ciphertext and encryption, decryptions. Before going to discuss about this cipher, going to discuss about this point, let me say what is this ciphertext. Actually, this is ciphertext or you can call it as an encrypted text. It is a series of random letters actually and numbers with humans cannot make sense of it. That means human cannot understand what the value of that encrypted data is. That means the message what is encrypted, we cannot know how we cannot able to read through our eyes. That means everything will be in the form of digits. So we cannot mm, we cannot make in a English manner. Okay. So you can see here this is a public key and this is a private key. And is a ciphered public key is nothing but this is a key that is generated using this code. Okay, then after only we have generated an encryption key and decryption key. Let me discuss in detail here next coding part. Yeah, see, suppose the message vs text to be encrypted by ECC public and decrypted. So this is the original message. They are going to be encrypted, and then the server used to be decrypted. So now the encrypted message is in this way. So see now you can see here the above part to be texted by the ECC public key. This is the everything is converted into a numeric form. So if any third party vendor or some other hacker is going to know the information by cracking your passwords and he's going to authenticate in yourself and you want to know the information, so he cannot understand what is inside this. Okay, so then this is decrypted, right? So you can see after matching with the public key, now he is going to decrypt it. So now the decryption also matches with the original message. Okay, yeah, this finally you can see here encryption public key and decryption public key. And here plain text also, we can use this plain text also, like encryption algorithms takes plain text message. There's nothing but runs the algorithm in the plain text and produces a ciphertext. Just it takes a plain text as thing and it runs on the algorithm and produces a type ciphertext. That's the difference between the plain text and the ciphertext. Okay, thank you for view. Thank you, and thank you for listening to my video. Thank you so much.